Yeah. Okay. So let's get started. Yeah. So today we are discussing about the week 7 content of the class, which is about depreciation and depletion. Okay. So very important topic. You might have heard this term depreciation somewhere in here. If you are, nowadays people are doing equity market investing, etc. So when you study those balance sheets of any enterprise, uh, I think in profit and loss statement there is always one entry which is called as depreciation. Okay, somewhere there. Uh, so basically, uh, you know, I mean, the classic definition, etc. It was discussed in the class. So there is, I mean, you can refer to those things. But the point is, why do we consider depreciation, etc., etc.? So basic understanding about it is the main question. Okay. So what happens when you purchase something? So basically, there are two types of assets for any enterprise. First is called as tangible assets, and then something called as intangible assets. Okay. So tangible assets mean something which you can touch, okay, or physically you can uh, make. Its presence will be known physically or virtually, whatever you want to call it. For example, factories, various machine in the factories, uh, or your warehouses, godowns, etc., etc. Anything that is physically touchable or virtually possible to see, etc., etc., is called as tangible assets. So what happens if you purchase something? um, you must have heard, if you purchase some car or any automobile, as soon as you take it out of the showroom on the road, its price decreases significantly from whatever price you pay at the showroom, right? And why does that happen? Because as soon as you start using any machinery or any car or anything, it is considered as the asset uh, you know under working. Okay, so its value starts to gradually decay. In some cases, it will be gradual decay. In some cases, it will be sharp decay or whatever it is. Okay, it depends what scheme of depreciation you want to use. But depreciation is basically, in a broader sense, it's loss in value of your asset over the period of some time. Okay, and then there are some intangible assets. Okay, for example, if any enterprise purchase any other company which is called as acquisition. Okay, so uh, this happens quite often nowadays because the bigger players in the market, they usually uh, don't want other competition to grow and become a problem in the future. So what they do, they essentially purchase the physical assets of that smaller company as well as the brands that it has. Okay, so you might have seen such news quite often if you are into that domain. Otherwise, it's very common also. If you can just Google, you can find, because for tangible assets, its value, its useful life, etc., is quite well known, because over the period of many years, many industries use those things, and then you can have a general sense of all those things. But intangible assets, for example, if I you know uh, for example, very very good example is about this Coke, beverages companies. So essentially they are 95% water, 99% also, but let's say they are mostly water. But depending on their ingredients, which are the minor ingredients, you have various brands: Coca-Cola, Pepsi, even Fruity, etc., etc. So, if you want to purchase any of those companies and make part of those companies as your own, part of your own enterprise, you have to pay. You are not paying for the water that the company uses. You are paying for the brand value. Okay, that is called as intangible asset. Sometimes you have to purchase patents, copyrights, all those things, right? So those things you can't physically, you know, feel their value or it is very difficult to assess their value also. That is also very subjective matter of discussion, because if you Google, you'll see some news where somebody says that company A trying to acquire company B, but the valuation seems very high. Usually, it seems high only because what you are trying to do as a company A, which is the acquirer, you are trying to gauge the value of that brand for future. Okay, so by future, that means whatever number of years you want to take into account. Okay, because brands usually you can't predict their useful life as you do for machines. Okay, so that is one thing. But there also, since you are paying something upfront for a future benefit for your own company, that expense needs to be accounted for in your balance sheets, right? So that is where depreciation comes into picture, and basically depreciation is is a loss that you incur in your balance sheet for a certain useful life of that property or asset that you purchase. Okay, so that is the basic definition of depreciation. So then there are certain types of depreciation. So I think there is one question in your assignment which is not the submission deadline is still far away, so that's why I'm not taking the questions, but still this depreciation, there are certain types. Okay, first is the definition that you should all know. It is nothing but loss in value of an asset over time. Okay, loss in value of an asset over time. Okay, so sometimes instead of using time, they call it as useful life of the asset. Okay, you can define it that way also, but you should always remember that it signifies something which is a negative entry for your balance sheets for a certain period of time, because you pay for something upfront. Okay, and then you account for that going into the future. Then since you are paying upfront, you might borrow it from somewhere if you don't have enough reserves with you, and if you are borrowing something, then you have to pay interest on that borrowings, right? So because the lender will expect some interest, right? So in that case, you have to take the principal that you borrowed as well as the interest you have to pay up to the estimated useful life of that asset into account, right? So all those things are there. And why do you do it? Since it's a negative thing, since it's a bad thing, right? And since it's a loss on your account books, why do you do it? Because eventually it will be good for your enterprise. That's why everybody does it. Okay? It's not like this is something bad. Okay? Depreciation is a bad consequence, you can say, but it's for a good cause. Okay, because it will help to eliminate competition, because you can acquire smaller brands, and if you nurture those brands properly, they may turn out to be a very fruitful decisions in the future, right? So depreciation may be a loss for you in your account books, but the profits that it can bear are quite significant. Okay, so that's why everybody is okay with depreciation. Every company's balance sheet has depreciation, and nobody objects to it. So as long as you are able to generate more revenues to incur your expenses plus depreciations, etc., it's fine, no? Then you are net positive. And it's basically there are three types of it. You know, First is called as physical depreciation. So as the name suggests, physical means it's in the sense called tangible only. So what you can see basically. So if it is a tangible asset, it will wear and tear over the period of time. Or any of the components will get damaged for your whole part or something like that. Okay, so corrosion is also very famous physical depreciation root factor, because everything gets corroded. Okay? Except maybe you can say polymers, etc., but they also degrade. They don't get corroded, but they degrade over the period of time because of various agents. Then there is something called as functional depreciation. Okay. Classic example could be typewriters after the invention of internet or computers. At one point of time, typewriters were very widely used because the print media was the main, uh, main thing for the uh, spreading of the important news or anything, books, etc., etc. But after the advent of computers and internet, nowadays typewriters are replaced by keyboards, which are integral part of your laptops, computers, etc. So if some company had purchased significant number of typewriters when the computers were being invented, they had to write this purchase of typewriters off from their accounting books, right? Because now they are not functionally useful anymore because everybody is using computers, etc. Okay, so that's a bad luck, you can say, but that is the case of functional depreciation. Okay, because that technology became obsolete, or you know, it's there is no demand for it. For example, you can say 2G phones, uh, as compared to, let's say, in the context of India, if you consider 3 years back, you know, uh, not 3 years, sorry, 1 decade back, let's say 10 years back, 2G phones were like the top of the town, right? Everybody wanted them because that was the latest technology available. But now people are going, even 5G, 6G, like that. So that technology became obsolete. So if some company had purchased a unique technology in 2G spectrum business, just prior to the invention of 3G, 4G phones, etc., then they have to write it off functionally. Okay, that because it's a functional obsolete now, so that comes under the category of functional depreciation. Okay, and that's why many a times businesses go bankrupt, because what happens, if it is a functional obsolete kind of technology, you have to write it off. And the problem that comes is, if you are not able to purchase the latest technology using your reserves or borrowings, etc., you don't have any means to compensate for the depreciation, right? So what I mean is, if your revenues from your business are lesser than the expenses including depreciation, that business will be bankrupt soon, right? Because if you're not generating any profits, how can business survive? Okay, so those things are there. And there is something called as accidents also, but that is, let's leave that. Okay, and there is one note, because sometimes you see these kind of questions, because I think in some of the problems that professor took, he also mentioned this. For example, if you purchase some forest, etc., let's say you're a paper company, and wood is your raw material for your industry. So instead of relying on some third parties, you purchased a big chunk of forest. Okay, so when you purchase that, you pay for two things. You pay for the land that you are acquiring, forest land, and second is you pay for the trees on it. Okay, so the depreciation is considered only for the trees, not for the land. Okay, so why? Because land is not considered as a depreciable asset. Depreciable asset because it is considered to have unlimited useful life. Okay, so this is a common, commonly accepted convention in financial terms. If you acquire any land and then build a factory on it, then the factory expenses will be considered into the depreciation costs on your balance sheet, but the land acquisition is considered in the fixed assets. Okay, because usually, let's say that factory doesn't work out, but still you can sell the land, right? So the useful life of the land is practically considered as very long. So that is what this unlimited means. Okay. So if you get such questions, just you have to subtract the total expenses minus the land purchase cost and then calculate depreciation on that remaining value. Okay, so that is something you should remember. Okay, and then there are certain terminologies, so how to calculate depreciation. So this is the basic introduction of depreciation. So then the question comes, how to calculate depreciation. So you should always think about this from practical point of view, because if you would have seen many formulas, right? So we use this P symbol for first cost of asset. So first cost means the purchasing cost of asset that you pay to acquire the asset, or asset could be anything tangible or intangible. F we use for final or salvage value, final salvage value, or scrappage cost also sometimes it is called in some questions. Okay, so that means at the end of its useful life, if you scrap that asset from your accounting books, how much will you get? Okay, so it's like a raddi kind of thing, or scrap metal, something like that. And then there is something called as book value. Okay, so we use this term symbol for book value at the end of 8th year. Okay, so starting from 0, uh, book value. So basically book value means this p value, depending on the depreciation and number of years, it will go down, right? So bt represents that value, which is after subtracting depreciation from the initial first cost. Okay, and it is a at the end of every year it will be updated. Usually it will go down. Okay, book value always go down from P to F. Okay, so that also you can remember, always goes down, or you can say always decreases also from its initial value to its final value. Okay, over the period of its useful life. Okay, so that N is nothing but estimated life of the asset. Estimated, or sometimes they call it as useful life of an asset. Okay, now you should pay attention that it's an estimated life. Okay, so nobody knows. For example, if you purchase one machine, you generally expect it to work for, let's say, 10 years. But what if it breaks down earlier? Because there is something called as bathtub curve for machines also, right? So most of them stick to the stated life, but many of them break early, and many of them can work very fine even after the stated life. Okay, so that's why it's an estimation, because nobody knows, or nobody can say for sure that this machine will work for this many years. Okay, so it's just an estimate, but still, in practical world, we need some numbers to put in your accounting books. So that's why we take the help of experienced workers or experienced personnel in your company to determine this N. Okay, and even F, because the scrap that you sell today, after 20 years, what will be its value, or how much will it go for the same scrap? You don't know, but you ask, then you go back and you ask your one of your factory workers who's been working for 20 years, what was the cost 20 years back, and if I say sell the same scrap now, how much will I get? And then based on that, you can estimate for the future 20 years, something like that. Okay, so that is why it's all, this depreciation is very subjective. Calculation of depreciation cost is subjective matter, and that's why if you pay attention, if you can open any 5 balance sheets of any companies, none of them will follow the same formula for depreciation. Okay, even if they are in the same domain, more or less the numbers will be in percentage term close, but they follow different things, and it's allowed. It's not wrong, because nobody knows. You're trying to predict the future, and that's always subjective. Okay, So this is about book value, and then there is something called as depreciation charge during the teeth year. Okay, so that means in a given year, uh, how much depreciation cost or charge is carried on your accounting books. Okay, so during that given year. Okay, and then basically you have this recurring relationship, right? So BT is nothing but uh, BT minus 1 minus DT, like that. Okay, because whatever was the book value last year, you subtract the current depreciation charge from it to get the current book value, or at the end of current year, what is the book value that you have. And here also you initial book value will be P, because that's what you start from. Okay, and after 10 years, your book value will be F, which is your salvage value. So that those things are there. Okay, we'll see some problems. Now the question comes how to calculate the book value. So there are various types of uh, mm, depreciation, or methods, not types. These are called as various methods for depreciation estimation. Okay, methods for depreciation estimation. And the first one is the most famous one, which is called as straight line method. Okay, straight line method. We use SL as the short form for it. SL is not stop loss. Okay, because I have seen nowadays many people do equity investing and they use these terms. Okay, so it's very easy method, and that's why it's very common method, because it's very it's very straightforward. You just assume uh, something like this. This will be your time curve. This will be your, let's say, book value curve, something like this, and it will be a straight line. In the case of straight line method, it starts from P, it ends with F, and it will be N, going from 0. Okay, so basically at if you want to calculate anything after, let's say, T number of years or something like that, so let's say you are interested in calculating something after M number of years, then you just have to uh, you can use this, because it's a straight line, right? So you can get the value of BM after M years, basically what I'm trying to say. So you have to use the property of straight line, which is the slopes will be same if you take any set of 2 points on it. Okay, so here what is the slope? Slope is nothing but this angle, right? So these two triangles are similar, no? So you can just write something like this, no? Y2 minus y1. Okay, so let's say y2 is f minus p, that will be divided by x2 minus x1, so that will be n minus 0, and that will be equal to bm minus p divided by m minus 0. So therefore you will have bm equal to uh, m by n into it will be p minus f, right? That term. One second, let me just do the steps. I thought I'll skip one step in between, but I think that's not a good idea. Okay, so this bm minus p will be equal to m by n into f minus p. Okay, so therefore if you want the book value after m number of years, then this will be your general formula if you use the equation of straight line. But in this case, yeah, I mean, instead of writing this f minus t, because it's a negative number, right? So they write t minus n and they replace this plus with minus sign. Okay. So in general, bt is written as p minus t by n into p minus f. Okay. So this is the formula that was given in the class also. Because p minus f is the slope of this line. Slope of this line, straight line, is p minus f by n minus 0. So that is just n. And then there is something called as rate of depreciation. Okay. Rate of depreciation is nothing but we use this term because it is used in this declining balance method, etc. All the things. Okay. So this rate of depreciation is nothing but the inverse of your useful life. Okay, and into 100 if you want to use estimate in terms of percentage. Okay. So if in some problems they are giving you rate of depreciation directly, you can write this as b minus rt into p minus f, isn't it? Because 1 minus n is nothing but rate of depreciation. So all those things you can do. Okay. But the key takeaway is it's a very widely used method because it's easy to calculate and easy to tell also. If you want to convince somebody, uh, let's say auditors or investors, why are you doing this and why are you not doing it other way, etc., etc., they may not understand other methods which are mathematically intensive, but these methods are easy to explain also to some other peoples. Okay. And I personally know, there was I mean, there is one, I mean, the context is different, but one machine was there purchased for some, let's say, p value, and its useful life was determined to be 14 years. Why? Because the depreciation cost that was good. I mean, see, ideally it is the other way around, right? Ideally, you get the depreciation cost by assuming P, F, and N. But in practical cases, what is done is, because accountants are smart, so what they tell you is you should have this much depreciation cost. So based on that, you try to estimate N. Okay, so there was one machine. So the depreciation cost was fixed. P and F is also fixed. So the only variable that you can play with is N. Okay, so the N was N was chosen as 14%, 14 years. Why? Because once again it's an estimate, right? But it was chosen as 1 because 14 because then the depreciation rate comes out to be 100 by 14, approximately 6-7%. Okay, between something uh, 100 by 14, 7.14%. Okay, sometimes they take 16 years also, so that will make it 100 by 16, so 6.25%. So you'll see if you read any annual statements of any good companies, you'll see that they mention these things. Okay, what is the rate of depreciation? It may be not in the balance sheet because balance sheet is very concise. But if you read the annual statements, then you may find this information. What is the rate of depreciation that they have assumed? Okay, and again, it's an estimation, so they can assume anything as long as it doesn't make you know as long as it doesn't deviate too much from the industry standard. Okay, so let's take some problems on this. So there are 4 variables here, right? Not 4 variables. I mean, huh. So okay, so let's see. You have 4 variables, which is bt, dt, p, f, n, right? So I can, you know, uh, and these two variables are functions of p, f, and n, right? So basically the questions that are framed is basically, I'll give you all these three values and I will ask any one of these two, or I will give you this, ask these two and ask this one, like that. Okay, so I hope you understand the questions, how they are framed. Okay, so maybe we can take some problems just for the sake of completion, but this is how it is done. Even in your exam also they will go like this only. Okay, so yeah. Okay, so let's take one question where a tool is purchased for 5,000. Okay, and the estimated life is 20 years with salvage value of 1,000 rupees. I'm not writing rupees because you can write any currency, dollar, rupees, doesn't matter. The answer will be in that currency. Okay. And the question that they are using straight line method, find the book value after 10 years. Okay, so this is the question. So now in this question, if you just make the list of given data, you'll understand why this question and how this question is framed. So P is given as 5,000 units, F is 1,000, N is given as 20, and T is given as 10. They are asking 10, and BT is or B10. They are asking book value after 10 years. Okay, and you are supposed to use SL method. Okay, so now see, I told you, right, I'll give you these three, PF and I'll ask you BT or DT. Okay, so this is that type of question. So here BT will be nothing but P minus T by N into P minus F. So if you do the calculation, it will be 5,000 minus 10 by 20 into 5,000 minus 1,000. So that is 4,000 by 2, 2,000. So this B10 comes out to be 3,000. 5,000 minus 2,000 is 3,000. So this will be your book value after 10 years. Okay. I can frame another question also, find D5. So depreciation cost that you carry after during 5th year. Okay. So D5 will be nothing but, if you see what is the formula for D5. Yeah, I mean, see here, this slope is nothing but the depreciation cost that you incur during 1 year, right? So that is nothing but your DT only, and it is same for all years. Same for all years. Okay. So therefore, this D5 will be nothing but T minus F by N. That is 5,000 minus 1,000 divided by 20. Okay, so that is 4,000 by 20, so that is 200 rupees or whatever is the currency. Okay, and that will be same for all the years. Okay, so if I ask you D6 or D1 or something like that, so all of them will be equal to D5. That is the main idea of straight line method, right? The depreciation cost of depreciation, or you can say annual depreciation cost, is same for all years. Okay, so they may ask some question like this also, that during using SL method, what is the nature of annual depreciation cost, whether it increases every year, decreases, or even same, or you can't say. Okay, so the answer will be the depreciation cost is same for every year. Okay. Yeah, so it is not necessary to have this n in number of years. Okay, n could be anything. It should be unit of time. Okay, as long as it is a, since it's measuring the useful life of your asset, right? So I can give you one problem where a machine with initial cost of 40,000 is expected to have a salvage value of 8,000 after, not after, when replaced after 20,000 hours of use. Okay. Find depreciation rate per hour. Okay. So what I mean, this question is along the same lines. So here you will have P as 40,000, F as 8,000, and here N will be 20,000, but that is hours. Okay, and what they're asking is depreciation per hour using SL method. Okay, so straight line method is the keyword here. If nothing is mentioned in the problem, just assume it's a straight line method question. Okay. Ideally, they should mention which method you are supposed to calculate by or using which method. But if they don't, you can assume SL method and mention that in the answer. That since nothing is mentioned, we are using SL method. And then your depreciation rate will be nothing but the slope, which is P minus F by N. So 40 minus 8,000 divided by 20,000. So that is 32,000 by 22,000, 32 by 20, 33.2 by 2, so 1.6. 1.6 units per hour. Okay. So this is a case where you don't have any number of years. Usually you will see 99% of the problems with n, which is the useful life in years, because as I said, they are the entries of your balance sheet. So usually either they will be calculated in terms of quarterly basis or half yearly basis or yearly basis. Okay. But in some cases they may give you n which is in terms of hours or any other time unit also. Okay, so in that case you need to be careful. Okay, so this is about straight line method. Then the second method is nothing but the declining balance method. Declining balance method. Okay. We use DB as the acronym for this method. For straight line it is SL method. For declining balance method it is DB method. So now the question is, in straight line method you had the depreciation value same for every year, but in some cases it is not. I mean, as I said, depreciation is all relative construct, right, or subjective construct. So you may want to carry this entry equally for, let's say, some n number of years, but in some cases you don't want to. What you want to do is initially only you want to get away with the major chunk of your depreciation cost. Okay, so that's why this is a method where you have this method works on the assumption of asset value decreases faster during initial period of its life. Okay, and you can see the very practical example of automobile purchase. So you may have heard such things that when you purchase the automobile, as long as it is inside the showroom, it's okay. But as once it comes to the road under your possession, then the value decreases by 30%, 40%, 50%. I think depending on the geographical location, that percentage number changes. But that is the that is the classic example of DB method, because it works on the assumption that the new vehicle gets older fast initially, but once it is like 5 years old or something like that, then the depreciation is not that much like that. Okay. So here in this case, what happens? You multiply. I mean, this kind of trick is used in many places. Okay, so you might have studied something like moving averages in your operation research class, etc. So there also, sometimes the recent entries in your data set are more important than the older entries. So you use one weighting factor to give the more weightage to your recent entry as compared to the older entries. Okay. So the same thing is done here. Mathematically speaking, it's the same thing. You assign a weight, and that weight here is called as a factor, fixed percentage factor, which is multiplied to the recent book value. Okay. And then as you proceed to the next time periods, uh, since the book value decreases faster initially, later on the decrease will be slower. Okay, so mathematically speaking, it's the same thing. You're just basically you're using some weightage factor initially, so that the book value decreases faster initially, and later on it's not that fast. Okay, so what is done here is uh, something called as depreciation rate. Okay. So in the SL method, the depreciation rate was 1 by n. Okay, but here it is not 1 by n. Here it is assumed to be some constant. Okay, some fixed percentage constant. Okay, so alpha is the symbol used by professor, so I will also use the same. And what should be this fixed percentage constant? It depends on type of the asset, and how fast you want the depreciation cost to go down, etc., etc. Okay, so those things are there, subjective again, so you can't argue with that why you have chosen this or that. Okay, but the idea is depreciation rate is some alpha, and then your depreciation cost for any year is nothing but the function of book value of previous year. Okay, and the book value of current year comes out to be 1 minus alpha power t and pt p. Okay, so you can write this as the current book value is nothing but previous book value plus the depreciation charge in that year, right? So and then you put dt as this in this. So what you get? You get see, bt is nothing but bt minus 1, right? Bt minus 1 minus dt, right? So here it will be minus. Yeah, that's what I was wondering. Okay, so therefore it becomes 1 minus alpha if I replace dt by this alpha into b minus bt minus 1, right? So therefore if you go back in time, so therefore you get this relationship. After t years it will be just the it will become b0, and that b0 is nothing but p. Okay, so you are supposed to remember these two correlations, and then you can solve anything. Okay, so this is also called as sometimes basic declining balance method, or simple declining balance method. Okay, and the idea here is as book value which is your BT entry, decreases the depreciation charge, which is your DT, also decreases. Okay, so you don't carry depreciation charge equally for the useful life. Okay, so if you just want to plot it, you know, maybe it will look something like this. So it will start with P and it will go something like this. Okay, so it's not a straight line. Okay, so this is your BT curve, this is your time axis. Okay, so you'll start from P and you'll end up at some F, something like this. F will be your salvage value after the useful life of 10 years. Okay, starting from 0. Okay, so that's why initially you have a faster decrease in your book value, but as you go towards the end of the useful life, the decrease in the book value is not that significant. Okay, so that is why, you know, sometimes you might have noticed, see, in this period, this decrease in BT is not significant. Okay, and as a result, what sometimes it is done is uh, you know then in some cases, okay, not necessary always, in some cases, uh, when such BT decrease is very insignificant, uh, this declining balance method is replaced with or switched with SL method. Okay, you might have seen this, right, in our classes also. Uh, Usually that is done in some. We'll see some methods going forward, but the reason is that only that towards the end of the useful life, this decrease in BT is not significant in case of this thing, people declining balance method. So we switch it up to SL method. Okay, so those things are there. So what will happen when we switch it with the SL method? The graph after that point will be a straight line. Okay, so initially it will be a non-linear curve, and after the switching of the methods, it will be a straight line curve, a straight line towards the end of the useful life. Right? So that is how it is done. Okay, then there are some nuances or some problems you can frame out of this. Again, the idea is same. So here, how many variables are there? Again, you have book value, depreciation charge for current year, etc. Alpha, depreciation rate, D, F, and N. Okay, I'm not assuming the switching case here, but these are the variables. These are independent variables, and these two are dependent variables, right? So I can frame questions like that. Okay, so I'll give you out of these four independent variables, I'll give you four of them. I will ask BT or DT, or otherwise I'll give only three independent variables. I'll give you BT or DT, and I'll ask the fourth independent variable. That is how it is done, and it should be done like that only. Okay, so we'll take some questions just to give you the idea. Okay, so in this case, there is one asset of 50,000 rupees, no salvage value, so F is 0 given in the question, and N is given as 10, so useful life is 10 years, and depreciation rate is given as 0.1 or 10%. Sometimes they can make it as 10% also. And what they're asking is, using the declining balance method, find, let's say, depreciation charge for the 10th year. Okay, so this is what they're asking you to find. So we can go back to the question, this thing, problem, this formula. Okay, so dt is alpha into bt minus 1, right? We have dt equal to alpha into bt minus 1, isn't it? But what is the formula for book value? concept is bt into 1 minus alpha tn. That means, see, bt formula is 1 minus alpha power t into p, right? So what will be the formula for bt minus 1? That will be 1 minus alpha power t minus 1 into p, right? And that's what you have to plug in here. So alpha becomes, bt minus 1 becomes alpha into 1 minus alpha raised to 1 minus t into the initial fixed p cost. If f is non-zero, then that will again come into the picture there. One second. F doesn't come into picture here. Okay, so maybe, we should note this down. I don't think f comes into the picture here because you are multiplying book value, right, starting from p. So yeah, so f usually, so that is why first of all, the decrease is sometimes very slow, and many a times, you know, uh, after n years or n years, what happens in many cases, this book value after n years may not be equal to your f value. Okay, so in those cases, again, switching to SL method is good idea. Okay, because this is like the disadvantage of DB method, because DB method is not at all concerned with your f value, right? Because what it starts with is f, and then each and it starts with p, and then each and every year it is calculating that only, right? So this f doesn't come into picture in any formula. So it may happen that after n years, the book value that you get is not equal to your salvage value. Okay? So in such cases, what they do is, if book value is going below the f value, they will just stop taking the depreciation charge, or in some cases they may switch to SL method, or in some cases, if this BN is coming out to be less than the salvage value, take the DN 0 and for subsequent years also. Okay, so sometimes these type of accounting entries are also done. Okay, so let's not go there, but you should know. Okay, so here, coming back to the problem, what will be your D10? That will be nothing but 0.1. 1 minus 0.1 is 0.9, and it's t minus 1, not 1 minus t, it is t minus 1. So that will be 10 minus 1, 9, and then your p is 50,000, isn't it? So what will be this value? Just calculate. Point 1 into 0.9 raised to 9, 50,000. It comes out to be 1937.1. Okay, so this is your depreciation charge that you carry in the 10th year. Okay, and just for the sake of comparison, let's calculate the depreciation charge in the second year with the same numbers. So it will come out to be 0.1 into 0.9 raised to power 2 into 50,000, right? So the reason I am doing it is because you'll see the difference will be D2 comes out to be 4050, and if you can compare these two values, you'll realize, right, that the depreciation charge in the second year is significantly greater than the depreciation charge in 10th year. And similarly, if you calculate, let's say 10 years, instead of 10 years, if it is 16 years, then it is just 926. Okay, so like that, that is the beauty of this DB method, that your initial depreciation charge is more than that. Okay, and then I can ask you something like, B5, what is the book value at the end of 5th year? So you just have the formula for that, right? 1 minus alpha into power 5 into p, right? This formula, so that will nothing but 0.9 into power 5 into 50,000. So if you do that, you get something like 29,524.5. Okay. And let's say again, for the sake of comparison, if I calculate B2, that will be 0.1 square into 50,000, right? So 0.9 square into 50,000. No? So one second. That comes out to be 40,500. Okay. So now you see, this decrease in book value. Okay. So that is nothing but if I want to find, let's say, delta B5, which will be nothing but P minus B5. So, and here delta B2. That means the book value, change in the book value up to second year. Actually, shall we do it this way? No, we should not do it this way. Actually, this will not give you correct idea. We can do one thing. Yeah, maybe instead of B2, let's calculate B4 so that you'll have a good idea. Okay. So B4 will be 0.9 power 4, isn't it? So that will be 32805. See, actually, what I wanted to do is, I wanted to show you that B1 minus B2 is greater than B4 minus B5. Okay, so that is nothing but decrease in the book value is higher initially. But this will be nothing but equal to D2 only, right? And this will be nothing but equal to D4. So we have already shown such thing, no, in from this point 1 and 2. Okay, so no need to show it again. So let's leave that. Okay. So I can ask you all these things. Okay. So in some other problem, let's say, what I'll do, instead of giving you alpha, p, and n, all three, I'll give you two of them, and I'll give you the first one. For example, I can give you the balance or the book value after 10th year is nothing but 1,000 rupees, and alpha was, let's say, 0.1, and see, this is your t, right? T is 10 here. Okay. And what I'm trying to ask you is, what will be the p? Okay, so what is the first cost of that asset? So in such cases also, you have to use the same formula, Bt equal to 1 minus alpha power t into p, right? So that means p is nothing but Bt into 1 minus alpha power minus t. Okay. So Bt here, t is 10, so B10 is 1000 into 0.9 power minus 10. So what will that come out to be? 1000 into 0.9 raised to minus 10. Okay, so that gives you that the first cost of your asset was 2867.9. Okay, so these kind of questions can be framed. I'm not giving you the full sentence, etc., because it takes a lot of time and not required also, if you understand the concept. Okay, so this is how all these things are done in SL and DB method. Then there are modifications to this DB method, okay, or adjustments to DB method. Okay, so the famous one is nothing but double declining balance method. Okay. That is called as DDB. The only difference is here the alpha is not given to you. Here the alpha, which is your depreciation rate for DB method, this alpha. Where is it? This depreciation rate is nothing but equal to alpha is nothing but 2 times of 1 by n. If you want to express it in terms of percentage, you have to multiply it by 100. So it is nothing but this depreciation rate for DDB method is nothing but equal to 2 times the depreciation rate for straight line method. That is the main thing, and they can ask you such question in the sentence form also. Okay, so you should remember all these things. Okay, and sometimes it will be not double declining method. Sometimes they call this as 150% declining balance method. Okay, so in that case, nothing changes, all the formulas are same, only this alpha value will be 1.5 times of 1 by n into 100. Okay, that will be in percentage. So depending on whatever they want to give the constant, they may give you 125% DB method or something like that, any number they can give you. So just have to multiply that with the 1 by n. Okay. One second. Yeah, then as I told you, there is no guarantee that Bn will be equal to F, capital F, which is salvage value. So there are two ways to do it. If your Bn is coming out less than the F value, just stop the depreciation entry after that point, or you can switch to SL method before 2-3 years. Okay, and professor had taken one this thing, right, example, how do you switch to SL. Okay, so in that case, whenever the uh, you know DB depreciation, which is declining balance method depreciation value, comes out to be less than the straight line depreciation value on the unbalanced or undepreciated balance, then you are supposed to switch to SL method from DB method. Okay, so the switching criterion, you should remember. Will not take any example on this because most of the concept is taught by professor, so you can just revise that. Switching criteria for from DB to SL method, right? It is nothing but that the depreciation cost predicted by DB method, depreciation cost or charge, whatever you want to call it, if it is less than the SL depreciation on undepreciated balance. So this is the main stuff. They are not called calculating SL on from the initial, okay, the undepreciated balance, which will be nothing but BT minus 1 minus F, okay, divided by N minus T minus 1. Okay, and that should be less than alpha into BT minus 1. Okay, so very important. This alpha into BT minus 1 is not that big of a deal because that's just the book value that you get predicted from the last year's book value. But the RHS of this inequality, which is BT minus 1 minus F, which is the undepreciated balance, divided by the number of years left till the useful life. Okay, so that is this N minus T minus 1 represents number of years remaining at the Tth, after the Tth year. What I mean is, see, you'll start from 0 and go to N, right? Let's say you're somewhere here. So this N minus T minus 1 represents this life or useful life after nth or tth year. Okay, so that is how this formula comes. And whenever this inequality is satisfied, you have to switch from DB method to SL method. Okay. So we have seen in the class that how do we do that. Okay. So you can just revise that because there is not much to add to it. Okay. It's more or less that's it. Okay. Because it was explained with the help of one problem also, right? So I think uh, that is the maximum that it can be. It is there, okay, because these are some adjustments. Okay. So that will be, it was discussed in the second class of 7th week, types of depreciation, LS, SL method and DB method. That class only towards the end, professor had discussed all those things. Okay. So we'll not do that again and again because again, same thing, it will take time. So maybe we'll go to the next part, which is nothing but this tax depreciation methods. Okay. And very important method there was something called as modified accelerated cost recovery system method. Okay, so this tax depreciated or depreciation methods. So basically, as the name suggests, these are tax depreciation, right? So what it means is basically, um, what happens if you take depreciation cost which is significantly higher in the initial years, then your net profits will be lower, right? Because revenue minus expenses minus depreciation, etc., will be lower. So you'll pay lower tax. Uh, so that's how they want to do those things. So that will help you to get less tax in some tax schemes. Okay, in some geographies, usually US. Okay, so in India, I'm not sure whether this happens or not because this is a well-established method. So there may be some workarounds about it. Anyway, so here the thing is, instead of useful life, you know, uh, there is something called as recovery period. Recovery period is considered important than the useful life of the asset. Okay, so far we have been using the useful life, right? N, small n, but here we will assign certain recovery period for that. And why do we do that is because you'll see, I mean, that essentially this reduces your n, right, from a large value to smaller value, and then you will have higher depreciation costs, and then your net profits will be lower when you pay less taxes. Basically, that's why this is invented. And at the end of recovery period, we assume that the asset is fully depreciated. Asset is fully depreciated. Okay. Um, so what usually that means is we don't take any salvage value. Okay, we just assume that f to be 0. Okay, because we assume, I mean, we are not salvaging it, right? Because it will have some useful life. So the machine will be depreciated off from your balance sheet, but it will still be working, right? So salvage value comes into the picture at the end of useful life, not the recovery period, right? So that's why we generally consider f to be 0 in these calculations. And then there are two types, something called as general depreciation system or alternative. All those things are there, but for our purpose, the important one is this one. There was, I mean, uh, in these tax depreciation methods, the most important one is modified accelerated cost recovery system, which is MACRS method. Okay, so this is what is important for us as far as this course is concerned. So we'll use MACRS as the acronym for this. Okay, depreciation method you can put. Okay, and what basically is done in this method is nothing but there are it distinguish or it classifies your various properties into 6 recovery periods. Okay, so 6 recovery periods for personal property plus 2 recovery. Oh, not plus. I mean personal property and 2 classes for real property. Okay. And 2 classes for real property. I mean, the basic idea is, all the assets, mostly tangible assets that you can think of, they assign certain recovery periods to them. Okay, and the recovery periods will be smaller than the, or recovery periods will be shorter than the maximum useful life usually. Okay, so that is why you will get higher depreciation costs, right? So for example, one class is there and you might have seen this period table, right, in the class notes that are shared. So you have something called as recovery period. One classic case is a recovery period of 5 years for the class life. Okay, the class life may be between 4 to 10 years. Okay, so even if you have an instrument that is going out of the business in 4 years, okay, so maybe we should not write it this way. This is not entirely true, but still you can see, right, instead of, see, 4 and 10, the average is nothing but 7, right? But they take 5 only. They don't take 7 as the recovery period, they take 5. Okay, similarly for 10 to 16 years, they will take, instead of 13, they will take only 7 years as the recovery period. Okay, so you should mention that this recovery period is shorter than the average class life. That will be the correct sentence. Okay, not the useful life, because they take some range for useful life, which is called as a class life. Okay, this is nothing but range of useful life. So you can have multiple components coming under this. Okay, so what kind of properties that fall under this? I am just copying this from the class information only. You can refer for more details to those tables in the class notes. Okay, so this automobiles, etc., computers, etc., right? So computers, etc., will be written off in 5 years from your books. Okay, and the important thing is they tell you which depreciation method also you need to follow. Okay, so depreciation method also they tell you, and here it will be double declining balance method, switching to straight line method with half year convention. Okay, so half year convention basically means, see what happens in double declining method. If you calculate the depreciation charge for the first year, it is very huge. Okay, for example, if let's say for this period, I mean this case, the recovery period is 5 years, right? So the DDB rate will be 1 by 5. Okay, I'm just saying DDB rate will be 2 into 100 by 5. That is nothing but 40%. Okay, so This means that in the first year of your useful life of the machine, or the recovery period of first year, you have to supposed to pay 40% of its cost, or you have to consider it as depreciation cost. You know, this will be very high, right? Book value, right? So this is 40% of B, or book value. Okay, so which is significantly high in first year. Okay, so what they do is they don't consider first year as the full period for depreciation calculation. What they do is this half year convention represents, they only consider half of the year for depreciation calculations. So instead of 40%, you only pay 20%. Okay. So that is the meaning of half year convention. But because of this, what happens? Your recovery period was supposed to end in 5 years, right? But because of half year convention, you don't consider the first half of, half of the first year in the calculations. So additional half year after fifth year is there for the complete payment of depreciation costs. Okay, so the total recovery period is nothing but comes out to be 5 plus 1. Okay, so that comes out to be 6 years. That's why you might have seen when professor prepared those tables in the class, you would have noticed that the recovery was not completed in 5 years. They needed one more extra year. Okay, so there are such, total 8 classes are there, 3 plus 3 plus 2. Okay. The 6 recovery periods, and then 2 more are there, so total 8 things are there. And this is based on some law in the US, maybe not strictly applicable in India, but for the academic purposes we go with those things. Okay, and then essentially, you don't need to calculate this every time, because you can't, first of all. And what happens, this is switching to SL, right? Somewhere in between, when your DDB depreciation rate will be lesser than the SL rate, it will be shifting to the SL method. Okay, so what is usually done is, how to do the calculations, professor have showed you in the class, so I am not going to do that again, because that exercise takes a lot of time and it is already been done. So you can just revise those before your exam if you are appearing, or if you want to just revise, you can just revise that lecture, okay, in the week 7 syllabus. But what usually done is, you have such tables. Okay, so that is called as MA CRS method tables. Okay, these are available online. You can Google available online. You can Google them, because what happens, for these various 8 classes, they have these tables ready-made online. Okay, and you will notice certain things. For example, if you have certain years, let's say, I'll not draw the full thing, but I'll tell you what happens. For example, let's say your recovery period is on this, it is in the columns. Okay, it is in years. Okay, so let's say you are having a recovery period of 3. So if you do the calculations of the depreciation rates, okay, so basically these tables give you depreciation rate for each year, that you need to multiply with your initial book value to get the one second. Yeah, so how much depreciation rate per every year you need to apply. Okay, so if you have recovery period of 3 years, if you do these calculations, yeah, so what you will get is, you will get 33.33% in the first year. Second year, get 44.45. Third year, 14.81. And in fourth year, you get 7.41. Okay, so basically in the last year you shift to the SL. Okay, or I think third or fourth year, you can check that. I think this calculation was done in the class also. But it is very easy to understand later on. For example, if it is 5-year recovery period, the values that you get is 20, 32, 19.2, 11.52, 11.52, and 5.76. Okay. So when you end up with the same values, so this will be the where you switch to SL. Okay. So basically, uh, this is the point where you switched to the from your DDB method to SL method. Okay. And how do you identify that? In these tables, when the same values start to repeat for a given number of years. Okay. So this will be 5, 6. So you see the recovery period is 5, but totally you need 6 years to recover all of it. Okay. So like that you have significant number of years here, and then you have various recovery periods here. Okay. 7, 10, and so on and so forth. Okay. Some 8 classes are there, right? So you'll have 15, 20, 27.5, and 39. Okay. And like that, usually it is up to 25 or 30 here. Okay. Depending on how much uh, longer you want to go. But usually uh, you know these 27.5 and 39 also usually are not given. Up to 20 years it is given, and this is up to 21. So you can search for such tables, and this is what you'll end up with. Okay. So how do you calculate these entries in your tables? That is already taught to you, so you can refer to those things. Okay. And wherever these entries for a given recovery period, so that means in one column, whenever the entries start to repeat, basically that is the point where they shift from DDB to SL. One example, and you can expect such example in your final exam also if you are preparing for it. Because see, I don't think they expect you to remember these numbers. So what they will do is they will give you the values. Okay. For example, maybe we can take this question. Okay. So for let's see now. So for an asset, you have first cost as 90,000. Okay. Here they have not taken salvage value of 0. That is fine. In some cases they do. In some cases they don't. But usually speaking, it should be 0. But in some problems they can take non-zero also. Okay. So let's not put this. But what they do is at the end of your asset recovery period, the asset is fully depreciated. That is the definition. Strictly speaking, it should be f equal to 0, but in some problems they don't consider that. So you have to trade accordingly. N is given, which is sorry, not N, recovery period, because N doesn't carry any significance here, right? Recovery period is 10 years. Okay. And they have given you one additional piece of information that DT for or DT depreciation rate values for years 1, 2, 3, 4, and 5 are 10%, 18%, 14.4%, 11.52%. Okay, so they are given you up to 5 only, respectively. And what you need to do is find the book value at the end of year 4 according to this MSCRS method. Okay, so that is the question. And you can expect similar things in your exam also if they want to ask question from this point. Okay. So how do you do this is the question. Second, I'll just drink some water. Mm. One second. I have a doubt here. Let me just check. Yeah, actually this f now, I told you right that they consider f as 0, and they do because see here you'll see in this problem they have given you f value, but it doesn't come into picture anywhere. Okay, so we'll see. Yeah, so what is the sum of this 10, 18, 14, 14, all those things? Let me just check. Because see, one question or one confusion that comes, see in this case they have given you all these percentages also, right? So what is to be multiplied with it? P or book value of the previous year, that is one conundrum that is there. Okay. So usually we, one second. Okay, so one more note you should consider, this depreciation percentage. You know, we'll solve this problem, but this depreciation rates for each year are multiplied with P, okay, or initial cost, not the book value of preceding year. Okay, so what I mean by that is, depreciation cost of first year will be 10% is given, right? So that will be 0.1 into P. Okay, so P is 90,000. So 9,000 will be the depreciation cost for first year. Now the question is, what will be the book value after first year? That will be P minus D1, right? So 90,000 minus 9,000, that will be 81,000, isn't it? So now the question or the confusion comes to the next part, that how do you calculate D2, which is the depreciation cost for second year? So there the rate is given as 0.18, but here you need to multiply it with P, not the B1. Okay. So how do you, if you multiply by 18%, you get 90,000 into 18%, more than 9,000, right? So it will be 16,200. Okay. So your book value after the end of second year will be, now book value you have to subtract from B1, D2. Okay, so that will be 81,000 minus 16,200. So that comes out to be 64,800. D3 will be, they have given 14.4, right? So into P you have to do. P is 90,000. So if you do that, you get 12,960 as the depreciation in the third year. book value at the end of third year will be B2 minus D3. Okay, so that is 64,800 minus 12,960. That comes out to be 51,840. Okay. Similarly, because they are asking you to find the book value at the end of fourth year, right? So they are asking you to find B4. So you need to do it one more time. So the depreciation rate is 11.52% here. You have to multiply with P and you'll get 10,368. Okay, you can verify these numbers, but they should be more or less correct only. This will be B3 minus D4. Okay, so 51,840 minus 10,368. It comes out to be 41,472, and that is your answer. So this is how you need to proceed in this type of questions. Okay. So sometimes what happens, since you are multiplying everywhere by p only, so what you can do is you can directly calculate b4 also. There is direct method also, but you will not understand it if you don't do it stepwise. That's why I did it one stepwise. Then if you understand this part, you'll realize this is nothing but sum of all this depreciation rate percentages, 0.1152 into P. Okay, so P comes out and you just take 1 minus this. Okay, so if you see what I'm trying to say here is, see, if I just sum 0.1 plus 0.18 plus 0.144 plus 1152, this summation comes out to be equal to, this summation comes out to be equal to 0.5392. Okay, so that means out of the total initial P cost, depreciation is like 53.92% is already depreciated by fourth year. Okay, so this is nothing but summation of D1 plus D2 plus D3 plus D4. Okay, I mean, so basically this represents that factor only. Okay, so that is nothing but 0.5392 into P. That means by the end of fourth year, 53.9% of the depreciation cost is already accounted for, and that's why your book value remains only 1 minus this factor. Okay, so this is how you should proceed in this type of problems. And one thing that I mentioned about the salvage value, see, salvage value they are saying 45,000, but if you calculate the book value at the end of fourth year, it is coming out less than the 45,000, right? And this happens when you use this DDB methods or declining balance methods. This B4 is less than F given in the question, and it happens because we are using essentially DDB method, right, with switching to SL, right? But whenever you use DDB method, they don't know the F value. Okay, that is why these kind of things happen, that the book value that you get at the end of certain years will be less than the F value. So now how to do, I mean, what to do in such cases is basically, in such cases what is to be done is, practically speaking, not for this question, see, you should realize that at the end of third year the book value is 51,000, and at the end of fourth year it is 41,000 something, right? So what you do is, you usually in practical cases, this depreciation cost for the fourth year will be nothing but B3 minus F. Okay, this is what practically what is done. Okay, not for this question, but in practical saying, you, because you can't go below the salvage value. Okay, so that should not happen. Okay, so therefore what they do is they calculate B3 minus F. Okay, so what will be that? 45,000, right? F. So that will be 6,840. Okay, so they'll only put D4 as 6,840 in the account books for the fourth year, and if you do that, then you get B4 equal to F, right? Okay, so this is practically done. Okay, but since we are solving these questions using mathematics, you should know that whenever you are using DB method, any version of it, usually this kind of situation you can end up with. where your book value will be less than the salvage value, and practically speaking, you don't go there. You just do some adjustment in the last year and then make everything accountable or accounted for. Okay, so this is what DB method is. Okay, oh, not DB, this MSERS. Okay, uh, and after that there is one more important method which is called as sum of digits method, or sum of years digits method. Okay, and we use this SOID or SOD acronym for this. Depends on the question also. First of all, you need to calculate this SOD, which will be nothing but n into n plus 1 by 2, where n is your useful life. Okay, and this is similar to rule of 78 method that we saw in previous classes, right? Where you charge higher interest upfront in the initial period. Later on, the actual principal is recovered. Okay, more amount of it. So here also, depreciation cost in the first year will be n by SOD into P minus F. Similarly, D2 will be n minus 1 by SOD into P minus F, and so on and so forth. So last year you will put very less amount of depreciation cost, and this will be the number. Okay, so these kind of methods are also there. Okay, yeah, so maybe we can take one simple problem and then we'll move on. Okay. So they have given the P for your asset as 50K. Okay, useful life is 4 years. Salvage value given at 4,500 at the end of 4 years. Okay. What they are asking is find the depreciation cost for second year using this sum of digits method or sum of years digits method. Okay. So first of all you need to find this denominator for all the fractions, that is summation up to n natural numbers. That's why the formula is n into n plus 1 by 2. So 4 into 5 by 2, that is 10. 20 by 2 is 10. And D1 will be nothing but n by 10 into P minus F. So n here is 4, right? So 4 by 10 into P minus F. But they are not asking you to find D1. What they are asking you to find is D2. So D2 will be 3 by 10 into P minus F. Okay. So 3 by 10 into P minus F will be, isn't it? So this comes out to be 13,650. Okay. I'm not putting units in front of these big numbers. You can put anything, rupees or dollars, whatever it is. The main thing is concept. Okay, this is about the sum of years digits method. Okay. And then you can calculate book value, right? So this book value from here also you can calculate, right? So B1 will be P minus D1. Similarly, B2 will be B1 minus D2. Same formula. Similarly, Bn will be Bn minus 1 minus Dn. Okay, so like that we do. And this Bn will be equal to F in this case, because F is included in all the formulas, so eventually they will match. So that mismatch wala concept will not occur in these methods. Okay. So that is about SOD method. Then there is something called as units of production method. Okay, so these are quite straightforward methods. Okay. Units of production. Units of production method, not product. Okay, so we use UOP is the acronym for this, and it's very straightforward. Okay, so maybe Let's see if we have. Yeah. This barrel. So this method is usually used for uh, measurable measurable for example production of crude oil or production of number of units from a factory, something like that. Okay, or I mean not from a factory, from a machine. Okay, because every machine has certain uh, uh, rated capacity, right? So all those things you can do. For example, very simple example, you know uh, if one machine if a machine can produce, or process also you can put, uh, 1,000 toys, you know in its like in its useful life. Okay, the cost of machine, let's say it is 10,000. This is one imaginary example, so I'm just taking easier numbers. You can take anything. So and you can, let's say, find one second. Mm, yeah, I mean, find the book value after the machine produces, let's say, 500 toys. Okay, so in such cases, or let's say 400 toys, otherwise it is all the same. Okay, so how much units it produced from his useful life? Okay, so that much life it has already gone. Okay, so that tells you that the depreciation till the 400 toys comes out to be 400 by the total capacity of 1,000 into 10,000. Okay. So this much you should consider as depreciation cost. So that comes out to be 4,000. Okay, and then your book value will be nothing but P minus D. So 10,000 minus 4,000, 6,000. Okay. So basically, this is a simple illustration of this UOP method. So whatever is the total life products in terms of units of product, you assign that to the unit cost or the first cost, and then in the same proportion as it produces the toys, you decrease the book value in the same proportion. Okay, so this is this kind of thing. And then there is something called as depletion. Okay, so we had seen, the title says depreciation and depletion. So this depletion comes into the picture for natural resources. Okay, in case of natural resources, where uh, you know uh, it's like very difficult to predict the useful life for that natural reserve, or estimate those things. So therefore, we don't call it as depreciation. Depreciation is where you can estimate the useful life up to certain accuracy or certain confidence. But in case of natural resources like crude oil rig, or uh, branch or tree cutting for paper production, etc., etc., coal production from a mine, etc., you can't produce, or you can easily guess the useful life for that natural resource. So we use the process which is called as we use the term which is depletion, And then there are two methods under it. One is cost method. Another one is percentage method. Okay. So these were discussed in the class also, and you can there are some straightforward problems for this, and you should always remember in such cases subtract land acquisition cost from from initial cost, okay, for depletion calculation. Okay, that is very important note, because there are, as I said in the beginning of the class, you spend two amount of initial cost. There are two amounts. One is for the resource, one is for the land. And since land is not the depreciable kind of asset, you have to subtract that from the total cost, and whatever is the remaining, that is the cost that you pay for the only for the natural resource there. And then you calculate depletion rate, etc., depletion charge, all those things. Okay. For example, this cost method is similar to UAP method. Okay, this UOP that we just saw. Okay, so here also if you have some idea about how much barrels of oil you can take out from the uh, let's say oil reservoir or coal from the coal mine, etc., then you can do those calculations. So we can take one example for cost method also. We are talking about oil reservoir, let's say. Okay. Total capacity or total estimated capacity, because again these are natural resources. Okay, so these predictions are not that easy. So it can produce 350,000 barrels. Double R. Okay, and then uh, you know the initial cost for such oil rig that you need to put up is around 42 lakhs. So 42 lakhs. Okay. They have not mentioned land cost, etc. here, so no need to do anything. Okay. Selling price of the crude oil is $20 per barrel or 20 rupees per barrel, whatever. Okay. And 30,000 barrels are produced per year. Okay, so this is your annual capacity of your oil rig. So if depletion rate. Okay, so now this is the new concept that comes into this picture for this kind of calculations, because here you don't have a depreciation rate because you can't estimate the useful life that easily. So therefore for certain natural resources there are certain depletion rates. One table was given in the class also, in your class slides. For oils and gas it is 50%, gold, silver, etc., again 15. Coal it is 10%, because coal maybe you can extract for a longer period of time. Okay. And for clay, etc., it is lesser, 7.5 or 5%. All those things are there. Okay. And then if this is the depletion rate, then what is the allowed depletion charge? That is the question. Okay. So here actually asking this doesn't make sense, because this allowed wala thing comes into picture in the percentage case. So here just the thing is this depletion charge is nothing but this depletion rate, which is 0.15% into gross. Actually, it should be net. Okay, so net net depletion income. Okay, so net income that you incur. So that will be 0.15 into what is the net income? You sold 30,000 units for 20 rupees or $20. Okay, so that is 6 lakhs. 6 lakhs into 0.5, that comes out to be 90,000. Okay, so this much depletion charge for a year you need to carry on your books. Okay, actually it depends. If this capacity varies according to the year, then the depletion charge will also vary, because this comes into the picture. This remains constant. Usually we don't change the depletion rate for natural reserves. This also can change. So the selling price can also change. Number of units produced per annum can also change. But in this question, they have said that all of these things remain constant. So the depletion charge per year also remains constant. Okay, so like that you have to calculate. So how many years will it take to completely write off this initial cost? See, depletion charge per year is 90,000, so that is 0.9 lakhs, and you have 40 lakhs of initial investment. Okay, so 40 lakhs divided by 0.9, so basically 40 by 0.9, 42 by 0.9 you have to do. So 42 divided by 0.9, so that means around 47 years will be required for completely writing off this initial investment. Okay, and since you are using 30,000 barrels per year, in 47 years, how many barrels will we use? 47 into 3, so that is nothing but 30,000, right? 14 lakhs barrel. Okay, so, but you can take only 35, 3.5 lakhs, right? So yeah, so what happens? This selling price is not justified, so you may need to increase the selling price, but that is okay. Those things are not asked, so let's leave that. Okay, and then this percentage method. Here also you need to take only one thing into consideration is, see here also basically instead of this thing, instead of this cost of resource, what they do is yeah, I mean, instead of cost of 1 unit or something, they just have a fixed percentage to calculate the depletion amount. Okay, so whatever gross income you'll have, they just multiply it by a fixed percentage. Okay, so this gives you depletion will be equal to some K into gross income. Actually, it should be gross. I was thinking gross means this land also, but there are other concepts. I mean other things. So let's just take the gross income. Okay, and this number you have to fix. Okay, but the only restriction is that this depletion charge. Let's say DT. This DT should be less than 50% of all the taxable income. All the taxable income in that year. Okay, so whatever, if this T is in year, then you have to take year as the unit, or it is quarter, then you can take quarter. That is the only difference. Okay, other than that everything is same. I mean more or less same. Okay, and then there is the last thing, which is nothing but this amortization method of depreciation. Okay, so this is one last method. Uh, Actually, this method is we have seen this calculations earlier when we had some initial cost P or current value P, and then we wanted to distribute that current cost into some equal annuities, equal payment series for some years, number of years. So we had seen those formulas, right? A equal to P into, in bracket, A by P comma I comma N. So basically the same thing we do here. Okay. So here what we do is basically the depreciation charge for, let's say, kth period is nothing but P minus F into 1 plus R power minus N into R by 1 minus 1 plus R power minus N. Okay. So P is your initial cost. You discount your, so this should be N, right? Or if it is K, then this should be your, 1 second. What should be the index? That is the question. Let me just check once. Yeah, 1 second. Yeah, so these are nothing but see, N is useful life and DK is nothing but your annual depreciation charges. Okay, annual depreciation charges. Okay, so this is nothing but that A in that EPS formula. Okay, so this will remain same. So this annual depreciation charges will be equal. Okay, so they will remain same for all years, and all years go from 1 to N. Okay, and R is the rate at which uh, interest is charged when you borrow this initial cost. Okay, and F is the salvage value, and other things are pretty straightforward. Okay, but after that, the tricky part is, the important part here is the depreciation schedule preparation. Okay, that is the tricky part, because here what happens, you have the annual depreciation charges in your uh, I mean that by this formula, but the unknown that you have is book value. How do you find the book value? Because you just don't subtract this annual depreciation charges from the book value. Okay, you subtract from this DK, you subtract the interest on the depreciation, and then that value you subtract from the book value. Okay, so uh, book value calculation is tricky. Book value calculation is tricky. Okay, so how to do that? You please refer to the solved problem taken at the end of class. Okay, problem taken at the end of lecture, I think lecture 5 of week 7. Okay, I can do this, but it is already done, and we are also at the end of our class time. But the idea is, in this amortization method of schemes, depreciation charge calculation is not tricky because you get it from the formula. The tricky part is book value calculation at the end of each year. Okay, and how to do that, you should refer to uh, the class. Okay. Yeah. Okay, so with this we'll stop, and we'll meet next time. And next time I think it is about break-even analysis. So we'll see those things later. Okay. So thank you and bye. See you next time. Yeah, you can exit the class. I'm just just saving the PDF, etc. Okay, you can exit the class. Class is over. Yeah, thank you.